Welcome to the NGSS Assessment Academy Part 4. Today we're going to be talking about purposeful NGSS assessments. I am so grateful that you're taking your time to chat with us. My name is Brendan Finch. So I'm a former high school and middle school science teacher in LA. I taught for 7 years at LAUSD. Then I taught at a KIPP school in South LA, Green Dot, which is a charter network in Los Angeles, and then a virtual school called Kava. So today we're going to talk about purposeful NGSS assessments, but we at InterOrbit have a whole platform that we've built around rigorous assessments for grades 5 through 12. We have free pilots that we're offering up to teachers and administrators and students, obviously, until December. So if you're interested in getting started and you're looking for some pre-made assessments that you don't have to write yourself, we have tons of those. You can also add your assessments and benchmarks in, tag them with standards, and get ridiculously detailed reports, which I'll show you later. We have hundreds of phenomena at this point and thousands of assessments. We have these pre-made diagnostic, formative, and summative assessments, and then also you're able to go in and pull them together into benchmarks or whatever is most helpful. So on InterOrbit, if it is helpful, please go sign up and we'll set you up with a free pilot, or you can just look around on your own if you sign up for a free trial. And we have hundreds of phenomena with all these clusters of assessment items that are written just for the NGSS. This is not repurposed content. We think a lot of focus on how we're aligning our content to the NGSS, so go check it out. We also write custom assessments if you have benchmarks that you want written, or you have some benchmarks and you want them improved and tagged and better reports. You can send me standards and we'll create some sample assessments for you. Now let's talk about purposeful NGSS assessments. So today we're going to talk about that as an umbrella, and then we're going to get down into the NGSS basics. We're going to talk about phenomena and sense making, non-NGSS, which is like, what are you trying to prove? And then we're going to talk about one-dimensional diagnostics, two-dimensional formatives, three-dimensional summatives, and then we'll get into never write another assessment. For basics, we're going to talk about phenomena and sense making. This is the absolute the cornerstone of all assessments for the NGSS. If you want something to be three-dimensional, it needs to involve phenomena and sense making. So the first question you should ask whenever you have an assessment that where the purpose is to assess the NGSS is, do students need the phenomena to answer the questions? And if the answer is yes, then you're on the right track. Some attributes of a good phenomena are that it's specific, novel, compelling, complex. There should be something where students have never seen it before, and it's complex enough to be to require some sense making, yet it's also aligned to the content that y'all have covered. So now we're going to talk about sense making. So this is the other important part of those. And so sense making is going to be application of knowledge through a novel phenomena. Usually students are explaining why or how, and they're using both prior knowledge and skills. And this is where the three dimensions of the NGSS all come together and synergize. So if students learned about the relationships between heat and pressure prior, then you want them to draw a model to explain why the balloon deflates in this liquid if no gas is leaving the balloon. So here we have a phenomena. There's a thing happening. Somebody is very aggressively pressing a balloon into a liquid. You may want to tell students that this is liquid nitrogen or some super cold liquid, but the point is that if students learned about the relationships between heat and pressure, average kinetic energy, particle motion, and how that impacts things, then they should be able to explain, or should be able to give some explanation of what's happening in this phenomena. This is sense making. They're making sense of something novel they haven't seen before. The knowledge they're starting with is that less particle motion equals less pressure, and the skill is then representing that change through a model. So this is the gold standard. This is a sense making three-dimensional assessment. Typically, we'll also have questions that follow this that say, explain what patterns, what scientific ideas allowed you to draw your model, and why you drew the model the way you did, to make sure that we're hitting the cross-cutting concept as well for this particular standard. But this is an actual assessment from our site, and we're looking to have students apply knowledge of particle motion and pressure, and use modeling in order to explain what they think. Next, we're going to talk about so non-NGSS. This is, what are you trying to prove? So the goal with an NGSS assessment should be very, very clear, and the whole point of this webinar is that you should have a distinct purpose with all of your assessments. Are you looking to assess background knowledge? Are you looking to assess, progress towards a performance expectation? Is this a formative assessment where you're looking to kind of, meet those two things somewhere in the middle? It's really, really important that you have that defined. And most of the time when we see assessments that folks have sent us that are NGSS or are looking to assess the NGSS, they simply just aren't aligned. So I'm curious, what are you trying to prove, and why do you assess, and what's the purpose of an assessment? So ideally, it should be to provide data to support claims about learning. If your claim is that students understand the relationship between pressure and heat energy, that's different than, can students meet, this performance expectation? And then there are a lot of different, sort of like scaffolded steps in between those two things that you can go over. So maybe you want to know if students met your objective. Maybe you want to know if there are gaps in understanding. So I would say something that's just focused on skills, DCI only, is a great, we call those diagnostics on our platform. So we're looking at, did you learn what you need to learn in prior grade level bands? I taught middle school and high school in a context where students had a lot of gaps from prior grade level bands. Folks would come into my 6th grade classroom having almost zero science. Before that, I taught high school physics, and I would be teaching beginning algebra in that context. So I totally understand that not all of you are teaching in contexts where students come in with a lot of learning gaps, but if the goal is to assess those gaps before you start instruction on a new or more rigorous topic, that's a totally different perspective or purpose for your assessments. So now we're going to go through a few different examples of questions or pieces of knowledge, and these are, I guess, claims that we're looking to prove, and we're gonna tease them out and look into each of these different purposes and assessments and questions to make sure that everything is clear. Again, if you have questions, pop into the chat, use the Q&A feature, and Aaron will queue some of those up, and I'll stop later on and respond to them. So the first question is, are temperature, particle motion, and pressure related? Then it's, represent changes in particle motion in a model. Can students represent those changes? And then why does the balloon deflate? And these are all, with increasing levels of complexity and increasing levels of three-dimensionality as you go down. We're going to go over each of these questions one by one. The first one we're going to talk about are one-dimensional, and we call these diagnostic assessments because they're not really NGSS assessments as much as they're just diagnosing what students need to learn, before they can move on. The claim is, do students understand that temperature, particle motion, and pressure are related? So in this case, with this question, we're just looking at a DCI. So we just want to know, do you understand that these things are related? This question doesn't need a phenomena. You could have a picture of an elephant like dancing on a ball in a circus, and that would be ample for students answering this question. And so an example of this question is, so an increase in temperature will mean a blank in particle motion. This will cause the balloon to blank. So if students understand the content here and the relationship, then they should be able to answer this question. So the idea here, and if the claim is, if we're looking to, if the purpose of this assessment is, do students understand the relationship between these things, then that's great. This question is totally fine, but I would not call this an NGSS aligned question. This is just looking to, gather background knowledge, and, it's the same kinds of questions that we used to ask 10 years ago in classrooms pre-NGSS. There are also examples. So this is another manifestation of this, which is, can you model particle motion? And this one is a little bit tricky. It's 1D, and I'm going to say 2D-ish. So this is the most common thing that we see folks sending us when they say, here are three-dimensional assessments. And that is, I'm representing a DCI through a model. You don't need the phenomena to answer it. An example of the question here is, draw a model to show the differences between particles in a balloon full of air and in a balloon full of water. Students are absolutely drawing a model. That is what the question is asking. However, in no way is this asking them to make sense of it. There is modeling, in what students are doing. But if you look at, if you're a middle school or you're a high school science teacher, the level of the SEP that students need in order to actually, be modeling is way beyond students just showing something, showing the difference between particles. This is really just a representation of a DCI through a model. You don't need the phenomena to answer it. If you have questions like this, it's totally fine if your intention is for them to be sort of like a diagnostic or formative, but you can't use a question like this and say it's a summative question. It's definitely not three-dimensional at all. You're really just representing content knowledge, which is the DCI, through a model. Really, really important. This is the litmus test. So are you representing or are you sense making? Representing DCI does not require the phenomena. So as you go through your assessment, even if there are phenomena with the assessment, if you can answer questions without looking at the picture, watching the video, viewing the GIF, then you're not engaging in sense making. You're just representing a DCI. If you are doing sense making and it's a three-dimensional assessment, you can't complete it without seeing the phenomena. So if students, don't have to look at the graph or the chart or whatever process and can answer those questions, that this is not sense making, it's not three-dimensional. However, if there's no way they can answer the questions without looking at this phenomena, now you're getting at the good stuff. And if your claim is that students are meeting performance expectations and grade level band, the goal at the end of a lesson sequence or unit, then you must have the phenomena must be required in order to answer the questions. So it's a different purpose, but it's still relevant because obviously we need students to have that content knowledge. All right, moving on. If you do have students that are moving beyond that initial diagnostic and DCI only question, we can get into formative assessment. So let's talk about two-dimensional formative assessments. So now if the claim or the purpose is to show, can students represent changes in particle motion in a model? Now we're getting into, a little bit closer to what the NGSS is looking for. So two-dimensional assessment will use both DCI knowledge and SEP skills. In order to hit the middle or high school level of this SEP, it must include a changing variable. This is really important. It's kind of the difference. It is the difference between a one-dimensional assessment that's just representing and a three-dimensional assessment that is, or a two-dimensional or three-dimensional assessment where we're hitting the level of rigor. Now we're showing a changing variable in that. This is still not sense-making. This is important. This is not going to align with any sense-making state tests where students are doing really rigorous things. Draw a model to show how particles in a balloon change when heat is added. This is a two-dimensional question. Definitely, students do have to show a change. They absolutely are hitting the middle school level, at least, of an SEP, and they have to have particle knowledge about particle physics, at least relatively. That's what a two-dimensional assessment looks like. And then if we're making claims that we're writing benchmarks or summative assessments, it's really, really important that these have there's a very, very distinct line between all the diagnostics and the formatives and then anything that is summative or really looking to see, have you met or are you approaching the performance expectations? The 3D summative assessment, I'm going to give you two examples of these. So this is, the application of relationships between particle motion and pressure to a novel phenomena. So the knowledge that we're looking at here is, if there's less particle motion, there should be less pressure. So students understand that, the more heat energy an object has, the higher temperature, higher average kinetic energy of the particles in there, or the opposite of that, less means less pressure, then that's great. The skill is representing that change through a model. So you're not just representing knowledge, you're representing a change through the model, and you're making sense of something. So this is the question from the very beginning, which is draw a model to explain why the balloon deflates in this liquid if no gas is leaving the balloon. Probably students haven't seen this GIF before. This is one of our assessments. We created this GIF. The idea would be that they've learned about particle physics. They understand how pressure relates to particle motion, and they know how to model particle motion. So those are all things that should have been discussed earlier, and that's why those diagnostics and formatives are definitely important. But this question and adding something in addition to cover the cross-cutting concept for this performance expectation will make it three-dimensional. This involves sense making. They need to make sense of something they've never seen before. This is the NGSS. This is the good stuff. This is what we want students to be doing. So I'm going to give you another example of this, and this is looking at the relationship between particle motion and density. These are two different elements of a middle school physical science performance expectation. So now this is the opposite. So more particle motion equals less density. So those gas particles are going to be pushing out a little bit more and spacing out from each other, running into each other a lot more. You're still representing a change through a model, and this is draw a model to explain why the lanterns rise when the fuel burns. So students understand that that fuel is letting off energy. That energy is being absorbed by the particles, the gases inside the lantern, and that's causing them to push away from each other, push out, become less dense, and thus the lanterns rise. So this is sense making. We're looking at a novel phenomena. You're applying things that you've already learned about particle motion and about density. So there should have been one-dimensional and two-dimensional questions that preceded this. And that's important because if you want to assess progress towards a performance expectation, you need to make sure that you have a couple of steps before you hit the kids with this, because these are really complex. The three-dimensional sense-making questions are really, really complex. Awesome. So basically, we're going to throw it back, and the 3D summative assessment is really about tell me why. And I'm not going to sing it. Sorry, everyone. But if you're doing sense making and you're applying knowledge, in order to say that something is a summative assessment, it is three-dimensional, you definitely want to make sure that you're doing sense making, applying it, and then that's all in the context or lens of a novel phenomena. We definitely want to have all of those scaffolded assessments before, and explicitly calling out the cross-cutting concept. I'll get to this in a second. But the sense-making, application knowledge, novel phenomena are all of the elements needed in order to make sure that we have, that we're actually hitting the standards. So great questions, y'all. All right, and let's pull it all together. So clusters. This is how we like to write three-dimensional assessments. Writing one question where students are drawing a model and then explicitly calling out the cross-cutting concepts, DCI, SCP, all within that one question. It starts to sort of lean into a performance task. What we understand is that students will struggle more with those really, really complex problems. And you can absolutely have those in your assessment system and as you're building your assessments, but we recommend instead, so writing 2 to 6 questions around a phenomena. You can have some questions, that use evidence states and elements, just hitting DCIs, have some questions that are kind of formative, where you're getting up to the, to the end of that. And then, questions that are fully three-dimensional. All right, now draw a model, apply this knowledge, use the model to make sense of this, and then explain how patterns, apply in this context. So absolutely, you should have the cross-cutting concept called out explicitly in your questioning, but I don't recommend that being all a part of one question. I do think that students will struggle to explicitly be successful with mentioning each of those elements. Great. So never write assessments again. So we do all of this and we think about it a lot. So we have custom NGSS assessments, and we also have PD that we do. If you're interested in trying out this platform, or folks that would like to try out this platform, we would absolutely love to chat with you. If you're watching this after the fact, YouTube will post the link to our calendar, and you can click on that and find a time to talk with us. The next NGSS Assessment Academy is on. So tracking NGSS learning goals, and we'll totally talk about backwards planning for assessments. If that's not the very next one, then that'll be one that we talk about in the following, probably part 6, because we're just going to keep doing this for a long, long time. So please, Aaron will post the link in the chat for the next webinar. If you liked this, if this was helpful and useful to you, please register and feel free to share that out. So we think very, very deeply about the reports, and not just reporting on a performance expectation, but looking at all of the elements for a DCI. We tag all our questions with each of these things. Please, 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 if you're interested in checking out and tracking all of this data, we would love to have you pilot for free so you can gather some data and learn about inner orbit. We also have these longitudinal reports. So ideally that data is tracked from the beginning of a school year through multiple school years, and you can look at the progress of groups of students over the course of lesson sequence, a unit, or an entire school year, or multiple years, because it all it's all tied together. So we do this for DCIs, SCPs, and cross-cutting concepts. If you have questions after this, send me a message to brendan@inorbit.com. Follow us on Twitter. I don't know, give us a shout out if you want to. Y'all are awesome for doing everything you're doing for teachers and students. Thank you so much for joining us. Have a beautiful day. Thank you all very, very much.